This video is going to go over parent functions, the ones you need to know, as well as some attributes about them. So if you don't already know like domain and range or even, odd, neither, etc., go watch a video on that before you watch this video, please. That way you know what I'm talking about and how I'm getting the answers that I'm getting. So the first parent function you need to be familiar with is linear. Its equation is y equals x. It looks something along the lines of this. It's just a straight line. And it has a domain of all reals and a range of all reals. Linear is an odd function, and it is continuous. And then the end behavior, if you go left, you're going down to negative infinity, and if you go right, you're going up to positive infinity. So that is linear. All right, the next one that we're going to talk about is a quadratic function. Which is y equals x squared. It looks like a U shape. So it has a domain of all real numbers. But the range, the lowest this graph can go is 0. So the range is going to be 0 to infinity. Quadratics are even functions, and they are continuous. And then the end behavior, if you go left, you go up. If you go right, you go up. So both of these are going to be approaching positive infinity. Okay, the next one that we're going to talk about is absolute value. Absolute value is like a V shape. And the equation, it has these bars around the x. So it has a domain of all real numbers, as well as a range of, just like the previous one, the lowest it can go is 0. So the range on this is 0 to infinity. Absolute values are even functions, and they are continuous. And then just like the previous one, if you go left, you go up. If you go right, you go up. So both of these are approaching positive infinity on the end behavior. The next one we're going to cover is a cubic function. So it's like y equals x cubed. It looks a little different. It's like something like that. So it has a domain and a range of all real numbers. And a cubic is an odd function. It is continuous. And the end behavior, if you go left, you go down, so negative infinity here. And if you go right, you go up, so positive infinity there. Okay, the next one is going to be a square root function. So like y equals square root x. By the way, on a square root, there's a hidden 2 here by default that most people don't write. Okay, square root function looks something like this. And it might look like it levels out here, but it continues to rise forever. So the domain, the furthest left it can go is 0. And the furthest right is infinity. And then the range, the lowest it can go is 0 as well. Square root function is neither even or odd. And it is continuous. But having said that, you have to kind of specify it's continuous along defined values. Okay, the end behavior. On this one, you're only going to focus on the end behavior if you go right, because if you go left, it kind of stops at 0 anyways. So if you go right, it's going up to positive infinity. Another function that you'll need to know is the cube root function. So that looks like y equals cube root of x. It's similar to the cubic function, but it looks something like this. So the domain is all reals, and the range is all reals. It is an odd function. It is continuous. And the end behavior, if you go left, you go down forever. Looks like it levels out, but it doesn't, so negative infinity. And if you go right, you go up forever, so positive infinity. Okay, the next one that we're going to cover is rational. Rational equation looks something like this, like 1 over x. The graphs of rationals look really weird. There's multiple pieces, so you have one piece that looks something like this. And then you have another piece that looks something like this. And there are asymptotes here. So here's an asymptote at x equals 0. And there's also an asymptote at y equals 0. So that's going to restrict your domain and your range. In terms of your domain and range, there's two ways to write it. Option 1 is to write it as two separate pieces. So what I mean by that is this section right here, I'm going to do first and say, okay, that has a domain from negative infinity to 0, does not hit 0, then union with, and get the domain for the second piece over here, which would be 0 to infinity. Now, if you're lazy, sometimes your teachers will let you get away with just writing x cannot equal 0. It's the same thing. Now, the range is going to be written the exact same way. So this first bottom piece here, I'm going to write the range for first, so negative infinity to 0, union with. The top piece here has a range of 0 to infinity. And likewise with the domain, you can just write y is not equal to 0. Rational functions are odd. In terms of continuity of a rational function, they are not continuous, and the reason is because you have those green asymptotes. So that kind of breaks it up and throws infinite discontinuities. And whenever you write continuity, you're kind of supposed to identify where that discontinuity happened. So on this one, I'm going to put at x equals 0. All right, and then the end behavior, if you go left, or if you go right, both of these lines are going to level out at 0. So that would be my end behavior. That's a rational function. Okay, the next one is going to be a exponential function. So like y equals e to the x, for example. Exponential functions look something like this. So the domain is all real numbers. The range, though, the lowest this line goes is to 0, and it can't actually hit 0. So the range on this would be 0 to infinity, but not including 0. Exponential functions are neither even or odd. They are continuous. And then the end behavior, if you go left, you level out at 0. If you go right, you go up to positive infinity. So that's an exponential. Okay, the next one we're going to cover is logarithmic. You can just call it log. So like y equals log of x. Logarithmic equations look something like this. So the domain, the furthest left you can go is to 0, and you can't actually hit it. So 0 to infinity for the domain. The range, it goes down forever, up forever, so that's all reals. They are neither even nor odd, and they are continuous. And then in behavior, if you go left, or as far left as you can, this part right here would actually be wrong. You would need to write as x approaches 0. So that's this right here. It goes down to negative infinity. Now the right you can keep as approaching positive infinity. That's okay. And it goes up forever to positive infinity. Okay. Then one more. I saved the weirdest one for last. You're probably not familiar with it yet. It's the greatest integer function. So all right, so the equation looks something like this. It's like a bracket around the letter x. Now, sometimes you'll get some teachers that put 2 brackets. I'm going to stick with just 1, but some teachers might put this. 2 brackets around the x. So it looks really weird. It looks like a stair step. It looks like this. And it continues left as well, so something like this. All right, what this means is the domain is all real numbers. But the range is not. The range, I think I write it something like this, like, because the range is only the integers. It is neither even nor odd, and it is not continuous. All these little stair-step spots are jumps. So I would say jump discontinuity. And for greatest integer, we're not going to worry about the end behavior.